Okay, so get this. The notes on unsupervised learning, I gotta say, they're fascinating.
Hmm.
Really, we're talking AI that learns without a teacher, like pulling insights from raw data.
Yeah.
It's wild. It's almost like, like a detective, right?
Right.
Solving a case. But there are only these scattered clues.
Uh,
No witnesses, no clear motive.
what's really cool is we're getting past needing those labeled data sets.
Right.
With unsupervised learning, AI, it doesn't need instructions.
Wow.
It's more about uncovering those patterns, those relationships that we might not even know are there.
So instead of us teaching the AI, it's almost like AI is showing us what's hidden in the data.
Exactly.
I mean, think about the possibilities.
Yeah.
What if AI could detect diseases before symptoms even appear?
Oh, yeah.
Or personalized marketing so well, it feels like it's reading our minds.
Exactly. The key is understanding how it all works.
Right.
Those core methods,
Yeah.
like clustering. You know about grouping similar things together.
Uh-huh.
But the way AI does this, it's pretty remarkable.
Okay, so walk me through this a little bit. How does it decide what's similar when it doesn't have those labels?
Algorithms.
Right.
Take k-means, for example.
Okay.
It's not just finding the center of the cluster.
Mm-hmm.
Instead, it positions, like k central points,
Okay.
centroids,
Yeah.
to minimize the overall distance between data points and their assigned cluster.
Okay.
So it's like, strategically placing those like community centers.
Okay, yeah.
So everyone can get there easily.
Right.
But instead of locations, it's using data patterns.
Ah, so it's optimizing those groupings based on data proximity.
Yeah, exactly.
Now, I'm guessing different clustering algorithms, they're better for certain tasks.
Of course.
What if you're not looking for the average customer?
Uh-huh.
But those outliers, the ones maybe doing something fraudulent?
That's where DBSCAN is great.
Yeah.
Remember those fraud detection examples?
Yeah.
It doesn't rely on those predefined distances like k-means.
Okay.
Instead, it uses the density of data points.
Okay.
This lets it uncover clusters of all different shapes and sizes,
Uh-huh.
as well as those outliers,
Right.
the ones that don't fit neatly.
So it's like a detective who sees that subtle clue everyone else missed
Precisely.
because they were focused on the obvious stuff.
Exactly.
I like it.
And then, if we want to understand those relationships between different groups, there's hierarchical clustering.
Okay.
This one builds like a tree-like structure.
Right.
So we see not just clusters, but also subclusters within them.
I see.
It's like a company, right?
Uh-huh.
You have departments,
Yeah.
teams in those departments,
Yeah.
and even sub-teams.
Right.
Hierarchical clustering shows this kind of structure in the data.
That's incredibly helpful.
Yeah.
So we've got k-means, DBSCAN, hierarchical, but what about those massive data sets? Tons of variables. Doesn't that make it really complicated?
Oh, for sure. And that's where dimensionality reduction comes in.
Okay.
These techniques, they simplify without losing that crucial information.
So it's like condensing a textbook into a study guide.
Exactly.
Keeping the knowledge, getting rid of the fluff.
That's it.
How does AI even start to do that?
Well, one tool is PCA,
PCA.
Principal Component Analysis.
Right.
Imagine a 3D model of a city, right?
Okay.
PCA finds the axes where the city's shape varies the most, like height, width, and depth.
Mm-hmm.
Then it projects the data onto these axes,
Okay.
creating a simpler 2D map.
Wow.
But it still captures those essential city features.
So PCA is all about finding those key dimensions with the most information.
Exactly.
It's like distilling the essence of a complex structure.
Yeah.
Are there other ways to make the data easier for us humans?
Oh, absolutely.
Okay.
There's TS&E.
Okay.
Like, imagine understanding all the relationships between hundreds of galaxies.
Yeah.
TS&E takes that high-dimensional data and maps it onto a 2D or 3D space,
I see.
something we can visually understand.
Right.
It's like turning an astronomical catalog into a star chart,
Okay.
showing those galactic clusters and their relationships.
Incredibly helpful for visualization.
Yeah.
So we're not just simplifying, we're making it understandable.
Yeah,
Almost beautiful in a way.
exactly.
I like that.
And then there are autoencoders.
Okay.
They're neural networks that act like high-tech compression algorithms.
Okay.
They learn to represent complex data simply
Okay.
in an encoded form.
Yeah.
And then they rebuild it
Wow.
accurately.
That's wild.
Think of it like a blueprint from a huge building,
Okay.
capturing everything in a compact format.
So PCA simplifies, TSNE visualizes, and autoencoders compress. It's like AI is becoming a data architect.
Indeed.
I like it.
And these are just a few of the tools under the umbrella of dimensionality reduction.
Right.
And we're only just getting started with what unsupervised learning can do.
I'm ready to dive deeper.
Yeah.
So tell me, how does AI go beyond organizing and simplifying to uncovering those patterns we might not even know exist?
Well, okay, let's move into this area called modeling distributions and pattern detection.
Okay.
This is where AI, it really shines.
Yeah.
Showing us those hidden patterns
Yeah.
within, these complex systems.
Okay.
Think about, like, predicting the stock market.
Right.
Or forecasting the weather.
Yeah.
Right?
Yeah.
These are intricate systems. Countless variables.
Right.
Unsupervised learning helps us model the probabilities.
Okay.
Uncover those subtle patterns we might miss.
So it's like we're moving beyond grouping and simplifying.
Yeah.
And we're going towards a more predictive way of seeing how things work.
Exactly.
But how can AI handle that level of complexity?
Well, one approach is using Gaussian mixture models.
Gaussian mixture models.
Or GMMs.
GMMs, okay.
Imagine you're looking at customer spending.
Okay.
The data, it falls into like multiple bell curves.
Right.
Overlapping, representing different spending patterns.
Okay.
GMMs, they help us identify these hidden distributions.
I see.
It's like separating an orchestra into its instruments.
Right.
So we can hear each melody.
So we're taking this chaotic data and breaking it down to reveal that underlying structure
Exactly.
that's creating that complexity.
Uh-huh.
Are there other techniques for even more intricate patterns?
For sure. For those really complex ones, we use Boltzmann machines.
Boltzmann machines. Okay.
They're neural networks.
Yeah.
But with this unique ability to learn
Okay.
the probability distribution of data,
Okay.
even when it's super intricate, multi-layered,
Right.
they're like master puzzle solvers,
Okay.
piecing it all together from random fragments.
It sounds like they're doing some serious heavy lifting in AI.
They are.
But I'm curious, how do we go from understanding patterns to actually generating new stuff?
That brings us to generative models and representation learning.
Okay.
This is where AI goes beyond analysis, becomes a creator,
Wow.
generates new data that reflects those patterns.
That's incredible. So we're talking AI becoming an artist, a composer, a writer, creating like humans.
Right.
What are some of those leading techniques?
One of the biggest is the Generative Adversarial Network,
Okay.
or GAN.
Jan, right.
It's like a constant game
Okay.
of cat and mouse between two neural networks.
Oh, I see.
One generates content, the other checks if it's real. They compete, both get better,
Right.
leading to like super realistic content.
So an AI arms race, but for creativity?
Exactly.
Where are we seeing GANs making a difference?
Oh, everywhere. They're creating like photorealistic pictures, composing music, even making videos.
Wow.
Fashion designers are using them for virtual clothes.
Okay.
Experimenting with styles. Advertisers for personalized campaigns.
Wow.
And in entertainment for special effects.
So GNs are the rock stars of the AI world,
In a way, yeah.
constantly pushing the boundaries. What other models are out there?
Well, there are diffusion models.
All right.
Instead of a blank canvas, they take an image
Right.
and add noise until it's just static.
Okay.
Then they train a network to reverse it,
Uh,
basically generating an image from randomness.
that's mind-blowing, like rebuilding a vase
Yeah.
from just dust and fragments.
It is pretty amazing.
Yeah.
Diffusion models are making great artwork,
Okay.
photorealistic pictures,
Uh-huh.
even personalized avatars.
Right.
They're also used in research, like drug discovery,
Wow.
material science,
Okay.
opening up new possibilities.
So we've explored these methods, grouping, simplifying, uncovering patterns, even generating.
Yeah.
But how is all this impacting the real world?
Right?
How does it affect people like us?
Well, that's the important part, right?
Yeah. Yeah.
The applications, they're huge and growing all the time,
Uh-huh.
touching pretty much every part of our lives.
Okay.
For example, businesses are using clustering, like K-means,
Right.
to group customers by their buying habits.
Okay.
This lets them make those super personalized ads.
So instead of irrelevant stuff, we see things we're actually interested in.
Exactly. A win-win.
I like it.
And remember, DBSCAN?
Yeah, our outlier detective.
Right. It's great for fraud and anomaly detection. Makes our digital world safer.
Right.
Credit card companies use it to flag weird transactions.
Okay.
Security systems use it to spot unusual network activity.
So it's like a guardian, always watching for trouble.
That's a good way to put it.
Are there other areas where it's making an impact?
Oh, tons. In medicine and biology, it's used to analyze genetic information,
Okay.
helps researchers find patterns in diseases,
I see.
develop better treatments.
Okay.
It can also spot cancer cells in those medical images, potentially leading to earlier diagnoses.
So from personalized medicine to fighting diseases, it's changing healthcare.
It really is.
What about automation and robotics?
Yeah, well, unsupervised learning lets robots learn on the job.
Wow.
They don't need programming for everything.
Okay.
Imagine a robot in a warehouse. It can sort packages
Yeah.
without knowing what each one looks like beforehand.
That's amazing.
This adaptability, it's changing how industries work.
Right. Robots learning on the job.
Yeah,
That's a game changer. What about language and information?
absolutely. Natural language processing is helping us with language in amazing ways.
Really?
It's used to categorize documents,
Okay.
making finding information easier.
Mm-hmm.
Machine translation is getting better
Wow.
thanks to algorithms that see those subtle linguistic things.
Right.
And those AI writing assistants.
Yeah.
They're getting really good,
Oh, chess.
helping us write better.
So it's touching everything from what we buy to our health to how we communicate. It is.
It's a huge technology.
Yeah.
But with all this power, are there downsides?
That's a good question.
What should we watch out for as it keeps advancing?
Yeah. Yeah, you're right to think about the challenges.
Yeah.
Every powerful tool, you got to consider those things.
Mm-hmm.
And unsupervised learning, well, it's no different.
Right.
One of the biggest, I think, is that black box problem.
Okay.
It's tough sometimes to really get why the AI system reaches its conclusions.
Right.
Like, you get the perfect answer on a test,
Mm-hmm.
but you have no clue how you got there.
Yeah.
It can make it, well, hard to trust those
It's
results.
not just about being right. It's about understanding how it got there.
Exactly.
Especially in things like, healthcare or finance.
Oh, absolutely. Yeah.
Transparency's got to be huge.
Right. And then there's the data itself.
Yeah.
Even though we don't need labels,
Right.
it still needs a ton of data to work well.
Okay.
It's like trying to bake a cake.
But you only have a few ingredients.
Right.
You might get something,
Yeah.
but not that amazing cake you could have made.
So data quantity's key,
It is.
even if it's not labeled.
Exactly.
What about the processing power
Ah, yes.
to handle it all?
That's another big one.
Yeah.
So these algorithms, especially those neural networks,
Right.
they need a lot of computing power.
I see.
Think of it like training for a marathon.
Okay.
Takes time, effort, the right shoes, all that.
Right.
These
Right.
AI systems, they need the same kind of setup.
Right. So we've got the black box the data needs and the computing power.
Yeah,
Sounds like there's still work to do.
there is.
Yeah.
Before it's everywhere.
But even with all that, the future of unsupervised learning is, well, it's pretty amazing.
Okay.
Researchers, they're always making new algorithms,
Right.
techniques to make things more transparent, efficient,
Mm-hmm.
and computers are getting more powerful all the time.
Right.
So those complex calculations, they're becoming more manageable. It's like we're on the edge of a real AI revolution,
I think so.
where this is going to be huge,
Yeah.
automating decisions, finding hidden knowledge, even that AI creativity we talked about.
It's all happening.
It's pretty exciting to think about.
It is.
From medicine to robots, it feels like it could change everything.
I agree.
So, as we wrap up, what's the one thing you'd want our listener to take away?
I'd say this. We're all surrounded by data.
True.
Our online stuff, health records, money, even just how we interact.
Right.
Unsupervised learning, it gives us a new way to see it.
Okay.
You can find those patterns we wouldn't on our own.
Uh-huh.
It can personalize things for us.
Right.
Even help us make smarter choices.
I see.
The key is to be aware, the good and the bad.
Yeah.
Approach this with curiosity, but also think critically.
That's a great point. As AI gets more advanced, we got to stay informed,
Absolutely.
understand how it's changing things,
Yeah.
and how we can use it responsibly. So to our listener, think about all the data you create every day.
Mm-hmm.
What hidden patterns are there?
Right.
What could AI tell you about yourself?
It's fascinating to think about.
It really is. It's a wild time to be looking at all this
It is.
data, AI, all of it.
Yeah.
We hope this deep dive has given you a taste of what's possible
Me too.
with unsupervised learning.
Lots to explore.
Keep exploring, keep learning, and until next time, keep diving deep.